Welcome, geometry students, to Unit 1.2, Points, Lines, and Planes. You're hearing the voice of Mr. May, and I will be walking through this lesson with you. As always, please make sure that you have your guided notes with you. We'll be completing those as we cover this lesson. And with that, let's begin. Our learning targets, we have 4 of them. And learning target number 1 is I can identify plane figures including collinear and non-collinear points using appropriate mathematical symbols. As you can see already, the main verb that we're going to be working on is going to be identify. That's going to be in our first 2 learning targets. That means given usually a diagram, and we'll work with diagrams quite a bit in geometry. Can you identify particular aspects of it? And most of the time, these aspects are going to be revolving around vocabulary, words, and terminology. In this case, the terminology that we're going to learn is going to be collinear and non-collinear points. So in learning target number 2 is we are again identifying, in this case, plane figures including lines, segments, rays, and angles. Once again, vocabulary, words, and terminology that is going to be extremely important throughout geometry. So it's very important that you understand not only the vocabulary but the concepts involved with them. Learning target number 3. We're going a little bit more in depth once we get to this learning target. We're going from identifying to actually modeling. So now we're going to model plane figures including collinear, and this should be non-collinear points. So let's go ahead and add a non in there. Non-collinear points using appropriate mathematical symbols. And I can model plane figures including line segments, rays, and angles using appropriate mathematical symbols. So once again, we can see that we're going to learn the basics, and then we're going to go a little bit more in depth as indicated by the verbs highlighted in pink. And then we're using the same vocabulary words and terminology throughout this unit. But remember, geometry is foundational in the sense that we learn terminology and then we use that terminology throughout all of our units. So very important that you pay attention to this. So let's consider, and really where I want to begin is thinking back in history and really kind of ancient history. The thought is looking up at the night sky may have been some of the very beginnings of geometry itself, and a lot of the geometry that we'll be studying can actually be found in the night sky. Just by looking right now at this photo of outer space or the sky, you can immediately probably start to pinpoint some features of it, and the first of them may be the actual points. You may see some points, and that's kind of what happened in ancient days. They were looking up at the night sky and they started seeing points, and so they started just kind of notating where these points were. And once they started seeing these points, they started watching systems about them, and they started noticing patterns. But when they started discussing it and telling stories about it, it became difficult to really just say, hey, that point up there in the sky that's a little bit to the left of that other one, that these 3, as you can see, that it becomes a bit confusing when you start really using abstract terms and generalizations when trying to describe elements of geometry. So the system started becoming more standardized. And so they started giving names to these aspects that they were seeing in the sky and in nature around them, and also in their everyday life. I'm using just this example of the night sky because it often shows patterns and things that we use. So in this case, we're looking at these stars, but in the sky they look like points. And so we started seeing these points, and not only do we see points, now our mind starts doing things like connecting these points. And when you start to connect the points, we start putting what will become known as segments between them. And when you put the segments and you draw them in with your kind of in your mind is how we do it when we're outside, but if we were to draw them, we start to see patterns, and then we start giving names to these patterns. And as you'll see, Really, with this particular pattern that we see, we often call it the Big Dipper. That is how we often call it when we're outside. We say, you see the Big Dipper, and in our minds, we automatically draw in the points and construct the points and construct the segments between them. And so this is kind of the beginnings, and then from here it becomes more and more formalized. We call these points, and then in between them we start calling them segments, but then that's still, once again, too generalized. And so now we start naming the points, and we'll call this point A and point B, and then we talk about the segment between A and B. And so as we go further and further, we'll take what became very generalizations and stories and descriptions of life around us in ancient days and really start to build a very standardized system that is very descriptive and very applicable to your everyday life. So I hope you enjoy geometry. I definitely do. It is one of the more applicable mathematical practices that you'll experience. And so with that, let's begin formalizing a lot of the concepts that we have already informally experienced in our everyday life. So a point we are probably mostly familiar with. A point is exactly what it looks like. But rather than keeping it very generalized, I think I used pink for points in the previous slide, a point is exactly that. It is a point. It looks like a dot. But most importantly, a point has 0 dimensions. 0 dimensions meaning it does not go anywhere. It doesn't have a direction. It doesn't have a depth. It doesn't have anything other than a small dot. So that is what a point is a small dot. But rather than trying to describe a small dot as a small dot and then with respect to another dot or line or something in a diagram, we begin to formalize it by naming these points. And so a point is named by a single capital alphabetical letter. And so when we name a point, we could name it whatever we want. It's just given a single capital letter. So in this case, I'm going to name this as point A. And now when if we only had a single point on a diagram, it would be easy to know what I was talking about. I'd just say, the point that's on the diagram. However, if you begin to collect points, and just to show you that I can name these whatever name that I want, it doesn't have to necessarily be in alphabetical order. I can call that H, call this M, call this G. If I were to leave out the names of these points, it would be difficult for you to understand exactly which of the 5 points that I was attempting to describe. I'm sorry, the 4 points. 1, 2, 3, 4, 5. 5 points that I was attempting to describe. However, if now I have a diagram and I say, point H, you immediately know that I am referring to this point here. And if I refer to point A, immediately you know that I'm referring to my original point A. So when we are naming points, remember that points are naming points with a single capital letter. So now we have a line. And a line is exactly what you may think it is, but when we draw a line, we have to do something very important. We have to put arrows on each side of the line. We have to put arrows. Those arrows are very important in that they show that the line, so the arrowheads show the line continues without end in 2 directions. So the arrowheads, without the arrowheads, we have to make the conclusion that the line stops somewhere. With the arrowheads, we know that the line will go on forever and ever and ever in that direction. So make sure when you are diagramming or constructing a line that you include the arrowheads. And so now that we have a line that's drawn, we can see that we now have 1 dimension. So a point, if you can recall, had 0 dimensions. And a line now has 1 dimension. So now we've increased the number of dimensions by 1. And so it's represented usually by a straight line with 2 arrowheads. Again, those arrowheads are very important. Another thing that we must recognize is that a line also must be named. If I were to have 2 lines, I'll draw a second line. And remember that I have to have the all-important arrowheads to show that it continues without end in 2 directions. And I have these 2 lines. And if I were to say the line that I am referring to is doing something, you right now do not know which line that I am referring to. I have 2 to choose from. So we also have to name lines. And the way that we go about the process of naming lines is we use the points that are on the line. So in this case, we have 2 points on this line. We have 2 points on this line. And I'll go ahead and name these X and Y. And so when we name a line, we use the points on the line. Now, technically, a line could have infinite points. And so what I'll do is I'll just add some other points here with lines. And actually, let me keep this with the same color. So I could add an infinite number of points on here. And going back and forth here, let's make that blue. And I could call this R. And I could go ahead and I can add technically as many points that I want. However, when we name a line, what we do is we choose 2 points as the name. Okay? So we can choose any 2 points. It does not matter. Now, since I've only labeled 2 points in this top line, I'll have to use those 2 points. And so in this case, I would name this as A, B, with the letters of the points written directly next to each other without space. And then what I will do is I will use the notation. This is the proper mathematical notation referred to in our learning targets. The proper mathematical notation is a line with the arrowheads above the points that are on the line. So in this case, when I look at this particular mathematical notation, I will know that this mathematical notation is referring to line AB that extends in both directions forever. Now looking at the second line that I drew, once again, I can use any 2 points. I have 4 points to choose from, but I only choose 2 as the name of this line. And so in this case, I'm going to use the original points that I had written. So I can call this line XY, again, no space between them. And if I want to show that it is a line, I will once again put a line notation above it with the arrowheads. Now, it is not necessary for you to highlight the arrowheads in the notation. I'm simply doing that to show you the importance of those arrowheads with respect to a line itself. Because if you leave out the arrowheads, we no longer are working with lines. We're working with segments, which we'll learn about in a moment. So to denote a line, we must have those arrowheads. So a line segment or segment. Notice that we still have the word line, but we don't have a full line. We have a segment of a line, so only a part of a line. And so a line segment consists of endpoints. So we have endpoints, which means that it has an end. Remember, a line with arrowheads is without end. A segment has an end. It has endpoints. And so I'm going to draw in endpoints. So here's my endpoints. okay? And then I have a segment or a line between them. Now what this is saying is that my segment stops at my 2 end points, okay? I have an end on each side. And it also consists of the infinite amount of points in between them. Technically, this line is made up of an infinite number of points, but when all put together, it composes a line. And so once again, we have to be able to refer to lines by name, and we also have to be able to distinguish them from each other. And so if I had 2 separate lines, and these 2 separate lines did not have a naming convention, I wouldn't know which one I was referring to, or you wouldn't know which one I was referring to without a lot of in-depth description. And so once again, we are going to name them using, in this case, we have to use the endpoints. We must use the endpoints. And so if I were to call this X and Z, and let's put a larger point here in the middle that just so happens to have a name for that point. So when naming these, must use the endpoints as the segment name, okay? And so my endpoints in the top segment are endpoints A and B. I'm writing them side by side once again. However, when I notate it with the proper mathematical notation as in our learning target, rather than putting arrowheads, I'm going to show that it is a segment that does end at point A and point B by putting the dots or points at the ends of my segments. I'm going to put endpoints on my mathematical notation in the name. So now I know that I have a line segment that begins and ends at points A and B. Now in the example below, I can name this in several different ways. So if I were to name a segment XY, so if I were to name it as XY, I want to show that it is a segment, so I'm going to put endpoints in the notation. I am actually referring to the portion of the segment between X and Y. That is all that I am referring to when I name a segment. That portion of the possibly larger segment. I could also name a segment if I wanted to. I could name this segment a different segment as YZ. Okay, and I want to show that it is a segment. So once again, I will draw endpoints on my notation. And in this case, I am only referring to, I'll do this, and I am only referring to the portion of the segment contained between the endpoints of Y and Z. And then finally, I actually have a third segment, and that third segment is all the way from X to Z. So if I want to name the segment from X to Z, can't name it XY, I would actually have to name it XZ. And I would show that I'm referring to the segment that ends at those endpoints by putting endpoints in my proper mathematical notation. So once again, the distinction between a segment and a line, a segment has endpoints and a line has the arrowheads. Notation is extremely important in geometry. So please make sure you review the notation and make the distinctions. Array. So once again, we have new terminology. An array consists of one endpoint. So now I only have a single endpoint called the initial point. So what I'm going to have is I'm going to have an initial endpoint. And now we could call this endpoint anything we want. I'll call it B. So we have point B is my initial point. And it consists of all the points on one. This is where we now make a distinction. One side of the endpoint. And so what's going to happen is this ray will extend in one direction, and that direction will be denoted by a second change the color so that we keep our color convention the same. Let's call it point P. And so what we have is we have an endpoint or initial point, which in this case we called point B, and all of the points in one direction on one side of the initial endpoint. And so a ray only extends forever in one direction, okay? Extends without end in one direction, okay? So it's kind of like a combination of a segment and a line. We take one end from a segment and one end from a line, and we put them together, and we call it a ray. So my part of the segment is my initial point, or point B in this case, and it's going to extend like a line in forever toward point P. And so when we name a ray, we have to be very specific. So the first letter in the name must be the initial point. Okay? So the first letter in the name must be the initial point, okay? So in this case, my initial point is point B, okay? Point B is my initial point, okay? Let's call this number 1, number 2. The second letter in the name is the direction of the ray. So it tells us what direction it is going. And in this case, the ray is going toward point P. So we're starting with B. We're going to point P. And we have a ray with an endpoint at B moving in the direction of P. So when I see this notation, I know that I'm referring to a ray because it has an initial point moving in the direction of the ray. I know that my initial point is called B and it moves in the direction of point P. One specific thing I need to mention, and this is different from some of the other notations that we've used. If I have a ray, because a ray can technically move in either direction, it can go left or right, and I were to name this ray, let's call it XY. When I name this ray, my initial point is still Wrong thing. Let me fix this really quickly. My initial point is still y, because that is where the ray begins, at the end point. And so when I write the name, I will write the y first, because it has to be the first letter. My end point must be the initial point. My initial point must be the first letter. And then it's moving in the direction of x. It will be very difficult in the beginning, if you're not paying attention, not to write your notation in this manner. This is incorrect, okay? That is incorrect in the sense that if you were to write it in that direction, what you are saying is that your initial point is x moving in the direction of y. That's what that is saying. That is incorrect. What you are going to do is use the exact same notation on all of our ray names, putting the initial point first and putting the point above it, and then the arrow will always move to the right. Will always move to the right. So I'm going to put a little note here. Arrow always moves toward the right. The reason being is that is, first of all, standard geometry notation, and it keeps everything very easy to recognize when we are given a name. For example, if I'm given a name, let's call it WZ, Ray WZ, Ray WZ. If I'm given a Ray WZ, I can, first of all, I know that W is my initial point. I know that the ray is moving in the direction toward Z, and that it goes forever in that direction. So make sure that you keep the notation of always having the arrow moving toward the right, with the initial point or the end point being written first in the name of the ray. Opposite rays. Opposite rays are, again, we're working with rays. So if I were to have a ray, I know that I have a ray moving in from an endpoint in the direction of another point. And so let's call this CD. Now take a moment, see if you can name this ray. And if you were naming the ray, you should name it C as my initial point. D is the direction that it is moving toward. The end point is C, and it is moving toward D, forever in one direction. So I need the arrow, and then the arrow always moves toward the right. So I have a ray, but I'm working, in this case, with opposite rays. But the opposite rays, and actually I want to use a different color here. Let's call it opposite rays, because I worked with endpoints when discussing rays. I'm notated the endpoints in green, and so in this case I have my endpoint as C, but opposite rays share the initial point, but they extend in opposite directions. And so in this case, I would begin, for my opposite ray, I would begin at C, and I would move in the opposite direction from that. And I'm going to say that it's moving in the direction of, let's call it R. Okay? So now I have two rays, ray CD, but now let's name my second ray. My second ray, this one, don't get tricked by the thought of it, okay? Where's my initial point? Remember, rays always begin the naming convention with the initial point. My initial point is still C. What direction is it moving toward? The second ray that I drew. The second ray that I drew is moving toward R. Even though this is moving to the left, okay? I am still going to write the R on the right side. That is the naming convention for a ray. So my initial point is C. It's moving in the direction of R. And as I mentioned when discussing rays, initial point, the arrow always moves to the right. So in this case, I now have opposite rays. My two opposite rays share the end point of C. The first one I called ray CD, and it moves in the direction to the right in this case. And now I also have opposite ray to CD called CR, moving in the opposite direction. But even though it's moving to the left, I still draw my arrow moves to the right. So there are my opposite rays and naming them. A plane. So now we're moving up another dimension. So now we're working with 2 dimensions. Okay, so a plane extends in 2 dimensions and is usually represented by a shape that looks like a tabletop. Now, when looking at a plane, okay, we say looks like a tabletop. A lot of times you'll see it drawn in this manner. But even though we have sides on this plane, okay, I have sides here, we have to somewhat use our imagination and pretend that these sides extend forever in all directions, okay? This is a visualization. It's using our imagination, and we have to imagine that all of these sides really don't stop inside of the boundaries of those lines. We have to imagine that they extend beyond that and go forever in all directions. But we have to have some sort of naming convention, some type of diagram, so that we can actually work with a plane on a finite or a piece of paper, something that does have boundaries. So when we are naming planes, the way that we are going to name planes is we are going to name them by 3 points. 3 points located on the plane. Okay? So if I have, those are my points that are on the plane. They're named, let's just call them A, B, and C. And so if I wanted to name this plane, I would just name it ABC. So now I have plane ABC. And I could have just as easily called it plane BCA or CBA, CAB. All of these all refer to the same plane. We're using 3 points to name our plane. Collinear and coplanar points. Terminology here, in this case, has hints built into the word. So notice when we work with collinear, okay, when I'm working with collinear, inside of here you will notice that there is a word, and that word is line. And so collinear points are points that are on the same line. So once again, let's draw a line. Remember, I am drawing a line, and if I draw a line, I have to have the arrowheads. I draw a line by using points on the line. Oh, A, B, C, and D. And so all of these are on the same line. A, B, C, and D are all points on the same line. Therefore, we can say that points A, B, and C are collinear. They're all on the same line. If I had a second line, make this a little nicer. If I have a second line, and this line is line XY, I can say that X and Y are not on the same line as points A, B, C, and D, and that will be called non-collinear. Non-collinear. I'll actually I'll save that for just a moment, but non-collinear. So now that we've worked with collinear, more than likely you can determine coplanar. Once again, we have a hint inside the word coplanar. We have the word plane, so we know that we're working with a plane, and we know that they are points on the same plane. So if I were to draw a plane, again, a lot of times it looks like a tabletop or a piece of paper. It does extend in the same direction forever. If I were to have points on here, we'll call these points S, Q, and R. We can say that points S, Q, and R are coplanar. Okay? If I have a point that is here, and we'll call this point T, point T is not on plane SQR. Therefore, it is not coplanar. It is non-coplanar with those points. So collinear, remember the word line is contained in collinear, and it's points on the same line. And we have coplanar with the word plane embedded inside of it. So we know that we're talking about points on the same plane. Intersect and intersection. An intersection occurs when two or more have more than one or more points in common. Okay? So that is when two figures will intersect. So in this case, we'll work with a line. So if I have a line, and I know it's a line because I have my arrowheads, and I draw a second line. And I also know it's a line because I have my arrowheads, and on a line we will have points because that is our naming convention. And we'll call this line H, E, and T, and this we'll just call these A and B. And so now I'm going to just to refer to our previous discussion about naming lines, I'm going to say I have line HT, line HT, and just show you to highlight the fact that we need the arrows on both sides, the arrowheads for a line. And I'm also going to say that I have line AB, now we have these two lines and they're moving in two different directions, but what they do have in common, the one point they have in common is in the center. And that is the intersection or the actual point that is in common. So in this case, lines these lines, which we have called line HT and line AB, intersect at point E. So that is the intersection. And the thing about an intersection, we deal with intersections every day. When you're driving your car and we come to a stoplight or we come to a stop sign, those are at an intersection. That is a easy real life application of geometry. It's an intersection, and that stoplight or the area under the stoplight or between the stop signs are the points that the two roads have in common, and we call that an intersection. That is directly from geometry. We deal with that every day, and a lot of times we'll call the intersection names based on the two roads that intersect there. In this case, we're calling the intersection of these two lines based on the names of the lines and a specific point that they share in common. And so that is a specific example of where theoretical geometry, which is what we're dealing with here, is moved over into practical and an application of real life that we deal with on a day-to-day basis. And so example number 6, we're going to stop here. We will actually work that together. There may be a separate video referring to example 6 for you to go back and review. But for now, I just want to make sure that you have completed, I'm going to go back, completed your guided notes up until this point. And then if you want to, you may go ahead and attempt to work the examples on your own, and then we will go over them. As always, if you have any questions, please ask one of the math department teachers. We are more than happy to help you understand the content and clarify any questions. And as always, do look forward to having you in class, and have a great afternoon.